Welcome back to Miss Maths. We've got a new playlist in store. This is part 1. Let's start off with what a function is. It's where we have one corresponding y value for every x value. Here are a few examples you may be familiar with. The straight line function, the parabola, the hyperbola, and the exponential function. These you would have learned from grade 8 up until grade 11. What makes this a function is that, according to our definition, it is a 1:1 relationship between x and y, or a 2:1 relationship. That means for every one x there's one y, or for every two x's there is one y. Just to illustrate here on the Cartesian plane, you can clearly see at this particular y value, when we superimpose it onto our straight line function, it has one x value. Now let's have a look at the following structures. Here we have a parabola that looks like it's on its side and a circular function. Looking at it on the Cartesian plane, you can see at this particular x value, we now have two y values. This goes against what we learned in the previous examples, which was our 1:1 and 1:2. This is now a 1:many. One x yields many y. This means that it is not classified as a function. Now we're going to discuss inverses. To invert a function about the line y equals x, on the Cartesian plane we have a diagonal line passing through the origin. This is known as the line y is equal to x. This is the line about which inversions happen. Here are the 3 steps that you need to follow in order to invert a function. Step 1. One needs to swap the x and y variables. Step number 2. Now that the variables are swapped, you need to make y the subject of the formula again. And for the final step, step 3, you now need to write your function in the correct structure. That is, as y is equal to, or written as the inverse structure, f to the negative 1 of x is equal to. This will be specified in a question. Given p of x is equal to half x squared, determine the equation of the inverse of p in the form p to the negative 1 of x. Knowing that function structure p of x is just y, output, let's set it up in basic structure. Applying the rules, we swap our x and our y variables, and now we need to make y the subject of the formula again through basic algebra. So I'm going to multiply by 2 on the left and right to get rid of the coefficient. Then I need to get rid of the exponent through evaluating the root on both sides. Okay, and whenever we take the root, we need to say plus minus. Putting it into the inverse structure, p to the negative 1 of x is equal to, and now you list the function that you've just calculated. Let's see what this will look like on the Cartesian plane. The original function p of x, that is a parabola, right, going through origin. So they have drawn it here in green, and now let's see how it's going to look when I flip it about the line y equals x. I'm creating that mirror image, almost as if I had to fold it along this yellow line. Can you see how they would fold onto each other? That's how you know that the inversion structure is correct. The blue graph now represents our inverse function. Notice, however, that this graph we've obtained is not a function. And look at that. It's not conforming to the 1:1 or the 2:1, meaning it's not a function by definition. To mitigate this type of problem, let's have a look at how we would do that. We would do so by a process called restricting the domain. This means to limit the x values so that when we are doing the flip, it conforms to function structure. So if I restrict the domain to x must be greater than or equal to 0, you can see that on the green function, I'm basically limiting the domain. When I do it for the inverse function, it's going to be a 1:1 ratio. Can you see there on the blue function? That part is 1:1, meaning it is a function. Thank you so much for watching. I hope you have learned something and enjoyed the video. Please do drop a like, subscribe, and I'll see you in the next one.